Picture this, it's Monday morning, you've had your first cup of coffee and you're sitting in blissful serenity. Your phone starts ringing ominously. It's your receptionist. Doctor, you need to get to the practice. There's an emergency colonoscopy that you need to do. The patient's lubed up, gowned up, and ready to go. You rush to the practice, you open your GoodX, you type in your credentials, it's loading, loading, loading. Eventually you log in. But wait, there's no patient records, there's no clinical records, there's no diary bookings, there's no counts, there's nothing. That is a dark, dark day, especially for the patient. Alrighty guys, let's get into it. I'm not going to bore you with technical jargon or any of the deep technical things on this topic, but today we thought it would be a good idea for GoodX to talk to you guys about how we go about the important job of looking after and maintaining your data and keeping you online all day, every day. Alrighty. Panic. Don't know which slide we want to get to. Don't get bored by the technical jargon. Alrighty. Okay, firstly we're going to be talking about mitigating downtime. So there's a few things we're going to be covering today. Security is one of them, downtime is one of them, redundancy, and then we'll have a little bit of an outro. So everybody talks about your data being stored in the cloud, but what is that? Obviously your data is not stored in a cloud in the sky that's got rain. It's a physical location, it's a building that has your data inside of it. And inside of these buildings, these data centers, they're called data centers, many precautions are taken to make sure that there's A, power to the data center, and B, that the data center is safe and secure. So in terms of security, these buildings go to extreme lengths to make sure that your data is kept secure. There is CCTV, there's armed guards, there's man traps, there's all sorts of crazy things. These buildings are truly marvel of engineering marvels. It's like an airport, except for they don't actually want to welcome you there. And then in terms of energy, that's what they supply, energy and security. They have backup generators, they have batteries, they have, one of the data centers we are with in Johannesburg has actually got 2 substations feeding the power to that data center for in case Eskom messes up the one substation, they can just flip over to the other substation. So that's just the concept of what it means when we say that we keep your data in the cloud. GoodX makes use of data centers, and your GoodX web application, your desktop application, is kept safely and securely in a data center. So let's get into it. Alrighty, that is you. That is your GoodX web right there. It's in the cloud, it's on a server, and there's your GoodX instance. Everything is lacquer. You're busy working, everything is cool, and the next moment, boom, something goes wrong. Now this does happen sometimes, and why it happens is irrelevant. What's important is that when this happens, that we have a mechanism that can ensure that your data and your service is kept online seamlessly without you having to call in, and that you can immediately carry on working. How do we do this? So we have what we call load balancing. So you have multiple of your instances on multiple servers. In this case, obviously it just shows one server, but your GoodX web is actually not just one application. We run your application multiple times where something goes wrong. So then, boom, the one explodes. We have monitoring software. So there's a bunch of guys that sit in offices with big screens on the walls. People get notified there on the monitoring software that there's an issue with that node. Someone will go and tend to that, but whilst they're doing that, you can carry on working seamlessly as if nothing has happened. Awesome, alrighty, so there you go. But now the whole server explodes. That's a bit more awkward. Okay, how do we get around that? So in order to get around this, we need a better solution than just load balancing. Of course, load balancing does happen across multiple servers, but there's another solution, another mechanism of redundancy that we make use of, which is replication. Replication that happens on a binary level, which means the little matrix videos that you guys see with the ones and the zeros, that's binary. And we make a binary copy of your data to another server. So it's packed exactly the same way it was on the original server. So the data will be exactly the same. So it will look like that. Boom, the one server can explode with a flick of a switch, 1 or 2 switches. We move you over to the other server and you carry on working seamlessly. Your data is kept up to date. Real time, we can do this and you can carry on, and our technicians can go out to the data center and investigate what's happened and what went wrong in that scenario. Pretty cool. Alrighty, what's next? The whole cloud's exploded. That is very, very awkward. Okay, that has never actually happened to us before. But believe it or not, we are actually geared to deal with this. So we have geographically split data centers where we replicate in between these data centers over a secure tunnel, a VPN, that then safely sends the data from one data center to another data center, where we have a copy of your data real time. Okay, it lags by a few milliseconds depending on where it is in the world, but basically real time. It will be in another place and we can start serving it to you immediately. And as far-fetched as this may seem, we are lucky, we live in South Africa. We don't get earthquakes or tornadoes or natural disasters, so it probably won't happen to us, but we have riots and stuff like that. So if it ever is required, we actually have got redundancy for this, which is amazing. I think this is incredible. Alrighty, and that is how it would look. Your cloud explodes, boom, we flip over to the other side with a flick of a few other switches, and off you go, you carry on working, and you are none the wiser to these issues. We deal with them, and you can carry on doing your thing. Okay, there's copies of everything. So what is this? This is just an image to represent the ideology that we have at GoodX when it comes to keeping your systems online. So we essentially have in place redundancy of everything. From the top, in terms of your routers, to the lowest level of things, we have a copy of every single thing in case when something inevitably goes wrong, that we have got a redundancy in place for it. So this is throughout the whole chain in place to make sure that we can keep you online always. Alrighty, so those are a few of the mechanisms that we use: load balancing, replication, and inter-DC replication to make sure that we can serve you your instance at all times. Okay, that number, does anybody want to take a guess what that number means or represents? Not everybody at once, please. Alrighty. No, you know the answer, I can't ask you. Alright, so what this number represents, believe it or not, is this is how many copies of your data we have at any given time. It's crazy, we have 177 copies of your data at any given moment. So this is comprised of 48 backups that's taken every hour for the last 2 days. So every hour for the last 2 days, we have 48 backups. Then we have 7 for the last day, and then we have 4 for the last 4 weeks. So together, I think that's 59, times that by 3, and 3 of those at all time are essentially live, that we can then flip between and serve you if we need to. So we have 177 copies of your data any given time. Of course, that 48 and that 7 and that 4 that I spoke about is a rolling thing, so we delete from behind, and we keep the newest. And this mechanism we do with a thing called snapshots. It's very cool, similar to what you guys have on your phones. If you take a screenshot, so when you take a screenshot, whatever's on your screen is what is then saved as an image. We have a similar mechanism that basically does that with your data. So whatever state your data is in at that time, we take a snapshot of that, and we have that. And that is how we make those backups. Alrighty, this is all very cool. So why do we need to have all these mechanisms in place if we have load balancing, if we have replication? What happens if your data is poisoned? And let's really talk about it. What does data poisoning mean? So data poisoning means that your data is changed in an undesirable way, and this can happen through many vectors. A simple one that you guys are all at risk of is you can fire somebody and he can log in tomorrow and just change all your demographic data for your patients. So he can go and update your debtors' phone numbers, emails, cell phones, all of that stuff. They can go and maliciously change the data in an undesirable way. Another way that this can happen is via supply chain attacks, and this can happen, for example, a silly example is you guys switch and you send a request to medical aid. The medical aid can send back a result to us that we then send into your system. That could be a bunch of nonsense. So backups won't help for any of this because the data has then been changed on all of our backups. So how do we go about this? So of course, like I mentioned earlier, we do the replication. Therefore, the poison data on the one side will poison all the instances. So that is not great. So we need another way to get around this. I think we got the slides in the wrong order. So we do that through the snapshots. So the image of the camera, we can then simply say, okay, cool, 3 o'clock your data was poisoned, but we took a snapshot at 2 o'clock, for example, so we can restore your data to the 2 o'clock state before the poisoning took place. The caveat, however, of that is, of course, that you've now lost the data for the last X amount of time that we restored up until. So yeah, we are protected against data poisoning. very well. We have hourly snapshots to prevent anything like that happening. Of course, there are, just to touch on that again, there are mechanisms built within the system itself, like logging in the GX web system, where we can restore your data to as well from. But like we mentioned earlier, we want multiple layers to be able to revert back to in case the options are failing or there's something wrong. Alrighty, this number, 23,884. So earlier I mentioned that when there's an issue with one of your systems, one of our guys will pick it up on the monitoring software. We use Nagios on the screens, and everyone has it on their computers, on their phones, so we get notifications. This is how many checks we have in our environment for South Africa to make sure that we keep your systems online all the time. 23,884 individual checks that carry out every 30 seconds to make sure everything is running the way it should. If it's not running the way we want it to be, we'll notify, and someone will go have a look at it and can fix it without, well, hopefully before something happens. Alrighty, an onion, what a cool onion. Thank you, Cami, for the onion. Alrighty, so in cybersecurity, there's an ideology that sooner or later, whatever protection mechanism you have in place will be thwarted. Over time, as technology evolves, there will be new discoveries and new flaws and new CVEs. And therefore, when it comes to cybersecurity, our approach to it is like that of an onion. It must have multiple layers. So we put as many layers in place as possible to make sure that if we ever do have an issue on one or two of our layers, there are many other layers to cover this. So of course, we have geo-blocking at the router level, TLS, and HTTPS, and certificates, all that, blah, blah, blah. But what's important here to recognize and understand is that we as GoodX, we approach this with layers. Cool, we sound like we are very smart, but these are things that we did not always know. And we've learned them sometimes the hard way. And I want to share with you guys how we learned this. So of course, we partake on online forums where we reach out to the community that makes use of the similar technology that we make use of, that we can talk to them and speak to them so that we can learn new things. Another thing that we do is every now and then we are sent overseas. Some of our guys were recently in, I think, Los Angeles, and they got to speak with some of the developers of the underlying software that we make use of, that they can then engage with them and share the problems that we've experienced with them so that we can better learn and understand how we can resolve our issues. I have a note I want to see because I think I'm forgetting something. Give me a sec. Nope, I made no notes. Fantastic. Alrighty. So yeah, we reach out to community platforms. We reach out to community platforms. We talk to professionals overseas. We go to these people, and then of course we pay people. The third mechanism that we have is every year we actually do penetration testing. So we pay an external company, and we say to them, listen, this is our IPs, this is where we are, this is how you can find us, attack us, try and break into our system, see if you can get it right. They don't get it right, but there's obviously things that they can then show us that we can improve on. So every year we go about doing that. Cool, so we do all of this from our side, and as you guys can see, we go to extreme lengths to make sure that your data is kept secure and safe. But my question to you guys today is, when you give a new user login to your system at your practice on their Windows, their laptop that they take home, what do you do to make sure that your data is kept safe? Because this is a two-way street. We do our part of it, and you guys are responsible for your part of it. So how often do you verify that the users that you are allowing on the system only has access to what they need access to? What about the staff that has quit? Stuff like that. Do you guys consider anything like that? Lady in the front here looks very concerned. Alrighty, are there any questions, guys? No. Alrighty, thanks. Have a lucky day.